Dear students, we are solving the IB Math AHL past papers, and currently we are solving the IB Math AHL May 2022 paper 2 time zone 1 past paper. And today we'll be solving the question number 4 of this paper. You will be getting the links to all the previously solved questions of the other papers and the first 3 solved questions of this paper in form of playlists in my channel NS Online Math Tutoring classes. So without any further delay, let us start answering question number 4. The maximum mark is 7 and it says a particle moves along a straight line so that its velocity v meter per second after t seconds is given by v of t equal to e to the power of sine t plus 4 times sine t for t ranging between 0 and 6 seconds both included. The subpart E says find the value of t when the particle is at rest. It contains 2 marks. And we know when the particle is at rest, its velocity should be equal to 0. Okay. So we will be having the equation as E of t equal to e to the power of sine t plus 4 sine t equal to 0. Okay. So let us use it is P2, so paper 2, so we use the calculator and let us use the graph. Okay. Let us graph this function. Graph, so it is e to the power of sine t. I'll be taking sine x, okay, and plus 4 sine x. E to the power of sine x plus 4 sine x, enter. And we know that the time is between 0 to 6 seconds. So let us adjust the window. So window settings, it will be 0 to 6. Okay, fine. Fine. We are seeing when t equal to 0, v is having some finite velocity. It is not equal to 0. Means it is having rather a non-zero velocity. And it is having a positive velocity. That means it is moving towards a positive direction. And when t equal to 6, even at that moment, the velocity is not equal to 0. The velocity is 0 only at this point, between 0 and 6 seconds. Okay, so let us get the 0. Analyze graph 0. This is 3.34692. So t is equal to 3.4692 seconds, or t is equal to 3.35 seconds. Up to 3 significant figures. Coming to subpart B. Find the acceleration of the particle when it changes direction. It is containing 3 marks. So when the particle changes its direction, the particle comes to rest momentarily at that very instant. So over here we are seeing the velocity is positive from t equal to 0 to t equal to 3.34692 seconds. The velocity is positive, it is moving towards the positive direction. Then the velocity becomes negative after 3.34692. So the velocity, now the particle should be moving towards the opposite direction because the velocity has changed its sign. Velocity was positive initially, it was moving in one direction. Now the velocity is negative, indicating that the particle is moving in the opposite direction. That means it has changed its direction. When did it change its direction? When t is equal to 3.34692, where the velocity value is equal to 0. Okay, so they are asking for the acceleration when the particle changes the direction, that is when velocity is equal to 0. And we know that acceleration is equal to dv dt. Derivative of velocity with respect to time will be giving us the acceleration, or we may interpret this as the gradient of the velocity time graph. Okay? So we are having the velocity time graph given over here, and we have to get the gradient, that is dv dt over here. They will be giving you in the form of dy dx, because for the calculator this horizontal axis is the x-axis and the vertical axis is the y-axis, but we know that we are taking the horizontal axis as the time axis and the vertical axis as the velocity axis. So the gradient they will be giving as dy dx will be actually equal to dvd. Okay, so menu, and we go to analyze graph, and we go to dy dx and position. This is the position. Okay, and you see they have given us the answer. So dv dt at time t equal to 3.3492 seconds is negative 4.7144 meter per second square per, is it meter? Yeah, meter per second. So when or acceleration A is equal to negative 4.71 meter per second square up to three significant figures, when the particle changes direction. Coming to subpart C, find the total distance, okay, traveled by the particle. Fine. The distance, we know that if we integrate the velocity expression, we get the displacement. Okay, and from the graph we are seeing from t equal to 0 to t equal to 3.35, almost equal to 3.35 seconds. The particle is moving in one direction, and then after 3.35 seconds, the particle starts to move in the opposite direction. It is changing its direction. So the if we take the onward journey, the forward journey as the first one, as positive, then the second part is the backward journey. So it will be negative. If we consider the displacement, displacement is a vector quantity. But over here, we are interested in getting the distance, which is a scalar quantity. We are not interested in which direction is the particle moving. The particle is moving, so it is traveling through a certain distance. We want to know the total distance, that for which it has traveled. Okay, And for that, we have to take this integration because we need the distance we will be integrating. And I have not saved the velocity expression function, so let me write one. Let me write once more. So it is menu, calculus, and numerical integral, and it should be between t equal to 0 to 6. So we will be taking the limits, the boundaries as 0 and 6. And this will be the absolute value. That is this. Okay. And now we write the expression for p of t, this one. Okay. Which is e to the power of sine x plus 4 times sine x and this is dx. It is 20.75342. So let us take 20.8. 20.8 up to 3 significant figures. So first of all, let us write this. The subpart C. The part C is integration between 0 to 6, absolute value of the velocity function. We are integrating with respect to t. So this is the power of sine t plus 4 sine t dt, which is equal to 20.8. 20.8 meters up to 3 significant figures. Okay, this was also was equal to negative 4.71 meters second square. Okay, okay. So the total distance is, I can write this as d. D is equal to 20.8 meters up to 3 significant figures. So we have solved the question number 4 completely. And I'm Nilanjana Sanyal. I am an online IB Math A, SL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services. My students, and currently, as you are seeing, I am making videos on the IB Math A, HL past paper questions and uploading them in my YouTube channel and as online math tutoring classes. In case you are liking these videos, in case you are understanding and liking my explanations, please do like these videos and please do share these videos with your friends so that even they can get benefited by watching these videos. And please do not forget to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. And in case you have any question, any doubt, any confusion, please feel free to write to me in the comment area. I'll be trying my level best to answer clear your doubts. Okay? And thank you for staying with me till the end. We meet again very soon. In our next session, we will be solving question number 5 of the same paper. So till then, bye.